Hey folks, I'm Mr. Hartzler, and I want to talk to you about function notation. We're going to start right off with some examples. So as I look at this, I am going, what? That's a crazy equation, right? There's a whole lot of stuff here. They're saying h, some function, equals this whole big nasty thing. But what they really want is this coordinate point, x comma y. They want it to look like a coordinate point in the end. So I'm going to draw that. All right. I know it's going to be a coordinate point. That's my final answer. Whenever I'm given something like this, h and then in parentheses 1, that's my x value. So I already know half of my answer. I know the x is going to be a 1, but how do I find the y? Well, I'm going to plug that 1 into my x. So 3 times 1 plus y equals 10. So 3 times 1 is just 3. So 3 plus y equals 10. What's y have to be? So I have to subtract 3, and y equals 7. So I plugged in a 1, I got out a 7, so that means my 7 is my y component. Nice, that one's done now. Awesome. Now I got to find this one. Find g of 5, and then back up to that top with h of 2. This is a little bit more complicated. Let's find g of 5. Well, like I told you last time, that 5 in parentheses means I'm plugging in a 5 for my x value. So 5 minus y equals 2, right? Because that was my x. I'm substituting in a 5. Subtract my 5. Now negative y equals a negative 3, but that's if I multiply both of those by a negative 1. It's kind of hard to see down there, but that gets me then a positive y equals a positive 3. That's my g of 5. G of 5 gets me a positive 3 for my y coordinate. I'm going to add my h of 2. H with a 2 shoved into it is from way up at the top. So that's going to be 3, substituting in my x with a 2, plus y equals 10. 3 times 2 is 6, so I need to subtract 6. And then I get y to equal 4. Nice. And they're saying to add those two things up, and 3 and 4 gets me 7. How nice. And that's just going to be my answer on that one. I don't have to set this one up like a coordinate point. Just going to give us that 7. Let's go on and check out another one. These look a little bit cleaner. There's less h's and x's and y's and everything. But remember, f of x is still just like a y for us. So f of 2, that kind of matches up with our x value, right? So I'm going to substitute that 2 in for x. So it's going to be a now 2 squared minus 1. And 2 squared is 4, minus 1 gets me 3. So I would say f of 2 equals 3, or my x is 2, and my y is 3. So I could write this as the coordinate point 2, 3, though we often don't have to. Now this one gets a little bit harder still, right? This whole page is harder problems. So now I'm going to take an f function and a g function. I'm going to plug a 2 into the f, a 3 into the g. Once I've found f of 2, I then have to multiply by that 2 there. So let's find f of 2 and g of 3 first. F of 2. So I'm substituting in x's and 2's. So that's a 3 and a 2 plus 1. What's 3 times 2 plus 1? Type it in your calculator. You should get 7. All right. That's g of 2. That part's done. Okay. Let's go over to that's f of 2. Now we need to do g of 3. G of 3. I'm plugging in a 3 for my x value. And oh, look at that. 2 times 3 plus 1. This actually still gets us 7. How cute is that? But that's not exactly what it said to do. It said 2 times f of 2 plus g of 3. I know what f of 2 is, right? It's the 7 right here. So that's going to be 2 times 7 plus g of 3. I know what g of 3 is. G of 3 is this 7. What is 2 times 7? 14 plus 7 gets me 21. So all of that just comes out to a nice pretty 21. All right, we're almost done. Hardest ones, right? These are the rough ones. They're not going to be too bad for us, though. We can do this. It has a whole lot more going on, but I know I need an F2 and a G1, so I'm going to find those two things. F of 2 means I'm shoving a 2 into my f function. Everywhere there's an x, it's getting substituted with a 2 now. Since it was x squared, now it's 2 squared, and then it was a minus 1, so I subtract 1 from that. And what is 2 squared? Minus 1. Type that into a calculator, folks. You should get 4 minus 1 is 3. Then I need g of 1. So I'm plugging in a 1 wherever my x's are. And that's 3 times 1 is 3, plus 1 is 4. Plug that into your calculators, folks. Don't feel bad about that if you need to. All right. Then I'm going to plug those things into this, right? Remember, f of 2 is this chunk. G of 1 is 4. So this thing says f of 2. Well, I know that's 3. This says g of 1. Well, I know g of 1 is 4. And then it says out here, right, square that. PEMDAS says I have to do my exponent, or not my exponent, sorry. I have to do my parentheses first, right? PEMDAS. It's a bad P, but you get the idea. 3 minus 4 is negative 1. I then have to square that, and I get a positive 1. Nice. Yeah, I do my ones weird. Get over it, folks. This one is my hardest. Okay? Of all of them, this is the hardest one. It's all letters. I have this function, but I'm looking for f with an a plus h plugged into it. So, f with an a plus h plugged into it. Everywhere there used to be an x, I'm now going to plug in a plus h. So there used to be an x, a plus h is what I'm writing in instead of an x. And then I have to subtract 1. So simplify this. I need to distribute that 2. I get 2a plus 2h, and then that minus 1 still hanging out. I can't do anything with that. I know you want to. You want to write 5 or I don't know what you want to do, but you can't. That is it. That's as far as you can go. They're not like terms. This one has an A, this one has an H. Those can't combine, and then that one doesn't have anything. They're all different. Leave them alone. Then I need to find f of a. So I'm going to, instead of an x, I'm now going to substitute in an a. So it's still the same function. So instead of an x, it's now 2 times a minus 1. All right, so that both of those pieces are done. Now I have to combine them. This says find that big thing and then subtract the f of a from it. This is my big one over here. So I'm going to write that down. 2a plus 2h minus 1. And then I need to subtract all of f of a. So I need to use parentheses. Right? It's kind of like this whole thing minus that whole thing. So that negative gets distributed. So I have 2a plus 2h minus 1 minus 2a plus 1. Double negatives on that one when I distribute the negative through. That makes my 1's cancel. And that actually makes my 2a's cancel. And I'm left with 2h. I know it's weird that there's still a letter in it. It's our only one with a letter in it still. But that's just the way it is. Alrighty, and I do believe, yes, in fact, that is it, folks. I hope you have a great day. I hope you learned something. Make sure you don't do drugs and keep doing math carefully and with enthusiasm.